David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember you can adjust the playback speed to make it faster or slower as you like. Second, you can pause the video at any point to catch up on your notes or jot down some questions. Third, you can turn on the captions so you can read my words on the screen. Okay, today's lesson is about the 3 forms of linear equations that we're going to encounter in this course. So these are line equations, and there's just 3 different ways you can write an equation for a line. Actually, there's more than that, but we're just going to talk about 3. The one that you're probably most familiar with is called gradient-intercept, or sometimes called slope-intercept. Slope and gradient meaning the same thing. And let's go into that. I think you pretty much know this is probably going to be review. Y equals mx plus b. That's the most familiar linear equation form we've got. The m that's in front of the variable x is the gradient, that's the slope, and the b is the y-intercept, so that point would be 0, b. That would be our y-intercept. So let's take a look at a type of a problem we might do using this information. So commonly, you're given a little bit of stuff, and you're asked to find the equation of the line based on that stuff. So in this case, we're given that the slope is 3 and that it passes through the point 1, 7. So first off, we know that this equation is going to look like this. Y equals 3x plus b. Now, we're missing the b. That we don't know yet. The x and the y stay as variables because that's part of our equation. We just need to find the y-intercept. So pause the video for a minute, see if you can do that. Okay, let's see how you did. This piece of information is vital because basically we know this equation is satisfied with that point, so we can do a plug-in. I'm going to put in 7 for my y equals 3x, no, I'm sorry, that's all smudgy. Okay, that's fine. 3 times the x value, which is 1, plus b. So you see how we did that? We just put in our x and y where they fit in the equation, and we know this has to work because this point is on the line. We're told that. So now we can just solve for b. We have an equation with one variable. This is going to be 7 equals 3 plus b, subtract 3 from both sides, 4 equals b. So now that we know the b, we can write our equation, y equals 3x plus 4. And there you have it. So now I want to show you a quick and easy way to graph this equation just based on this information. Okay? So first off, we know it passes through the point 1, 7. So that's here. 1, 7. Approximately right there. Now we know the slope is 3. That's rise over run, so you go up 3 over 1. So we're going to go up, we are at 7, 8, 9, 10, and then over 1 more. There's our next point, and now we can draw like that. That's a quick and easy way to draw that line. Boom! Okay, let's look at point gradient form. Just another form of a linear equation. This one looks like this. Y minus y1 equals m times x minus x1. M is our gradient, just like before, and then x1, y1 is a point on the line. Now, if you're thinking back to our last example, you realize that we could use this form to get into that equation as well. In fact, it's going to be a little quicker. So we're going to do just that. Find the line equation for a gradient of 3 passing through the point 1, 7. Now, I want you to pause the video and do a plug-in step with this and that information and derive the equation of this line. Okay, let's see how you did. We've got y minus y1, which would be the 7, equals the slope, 3, times x minus x1, which is just 1. So there's the correct plug-in step. Now let's work the math on this. Y minus 7 equals 3x minus 3, right? We're doing our distributive property there. Add 7 to both sides. Y equals 3x plus 4. Now, if you remember that last example, this is exactly where we got. Let's do another example using the same point gradient form, although this time we're just going to give you 2 points. So find the equation for the line passing through the point 1, 3 and the point 2, 5. Now this is a little tricky. Your first step here is to pull out something from a previous lesson. Think about that for a minute. What would you do? And if you know what to do, go ahead and try that. Okay, so far you've been given gradient for these two forms, and you're not given gradient right now, but you can find gradient. And we have 2 points, x1, y1, x2, y2, so the gradient is going to be given by y2 minus y1 over x2 minus x1. And let's do our plug-in. Y2 is 5 minus y1 is 3 over x2 is 2 minus x1 is 1. So this is going to be 2 over 1 or 2. So now we have a gradient. So now pause the video again and use this information to find the line equation. Okay, let's see how you did. I'm going to use my gradient for here. I can pick either point and it's going to work just fine. I'm going to pick this one. So what we have is y minus y1 is 3 equals, my slope is 2, times x minus x1, which is the 1. Like that. So there's my plug-in step with the gradient that I found here using this point in point gradient format. So let's finish this out. Y minus 3 equals 2x minus 2. Add 3 to both sides. Y equals 2x plus 1. Okay, let's take a look at the last of our 3 forms for this particular lesson. It's called standard or general form, and words of warning, these are kind of generic terms. I've seen textbooks that call this standard form. I've seen textbooks that call this general form. So you really need to know your context before you can be certain what these terms will mean. And when we get into quadratics, there's different things going on. So you just want to pay attention to your terminology in your context. Okay, so here's what it is. ax plus by plus c equals 0. Okay, now this is pretty different. The other equations had y's on one side and x's on the other side. This one has everything on one side and the other side is 0. Okay, so that's really important. The second thing that's really important is that a, b, and c are elements of set z. And do you remember what set z is? If you guessed integers, you're right. So these cannot be fractions or decimals. They have to be integers like -7 or +20 or any number of things like that. Okay, so here's a typical problem you might see. Here's that same equation we've been playing around with. Convert it to standard form. So this is very much not in standard form. We need to convert it. So check this out. Everything is on one side with 0 on the other side. So all I have to do for this one is subtract y from both sides, and I get 0 equals 3x minus y plus 4. That would be standard form for this equation. Probably write it better like this. 3x minus y plus 4 equals 0. Okay? And that fits the conditions for standard form. So go ahead and pause the video and try that one. Okay, so this one's real similar. We just subtract y from each side. So I'm going to have 2x minus y plus 1 equals 0. And that would be my standard form for that one. Let's do that conversion the other way. A couple problems real quick here. Convert this to slope-intercept, to gradient-intercept form. Now before I turn you loose on an attempt, remember that gradient-intercept is the equation solved for y. So you just need to rearrange this so that y is alone by itself on one side. So go ahead and pause the video and give that a shot. Okay, here's how that goes. I'm going to subtract y from both sides and get 6x minus 1 equals negative 2y. Now I don't quite have y alone. I've got my minus 2 in front. So I'm going to divide through by negative 2. I'm going to switch sides. So dividing through by negative 2 leaves me with y equals negative 6 divided by negative 2 is negative 3x, and then negative 1 divided by negative 2 is 1/2 plus 1/2. Just like that. Okay? Now pause the video and try that one. Okay, let's see how you did. Oh, that's kind of hard. There's no y. Let's fix that. All right, now try that. Okay, getting y alone, I'm going to subtract 3y, or add 3y to both sides. I get 5x minus 2 equals 3y. Divide through by 3, and I'm going to switch the sides. So y equals 5 over 3x minus 2/3. Action. Let's take a look at two special cases, horizontal and vertical lines. We've already bumped into them a couple times so far in this unit. Let's take a closer look. So for a vertical line, x equals c. Now think about that standard form. Remember we had ax plus by plus c equals 0. The c would be your constant. So in this case, it's some constant. Let's say, for example, x equals 2. This is a full-on equation for a vertical line. We can even graph that. Here's my graph. 2 over on the x. It's going to look just like this. And what this means is that x does not depend on y. It's just 2. Doesn't matter what value of y is, x is going to be 2. And that's this line here going through x equals 2, right there. Y can be -1, x is 2. Y can be 3, x is still 2. I think you get that. So let's move on to horizontal lines. Very similar. Actually, before we do that, what's the slope? For a vertical line, what's the slope? Now, a lot of people would say, oh, the slope is infinity. Truthfully, it's not. It's undefined. And think about why that's the case. If you do a slope equation on this line, you're going to have 0 on the bottom of a fraction. And whenever mathematics bumps into that, we say undefined. So no slope. It's an undefined slope for, not no slope. It's undefined slope for a vertical line. Now let's take a look at our horizontal line. Similar, instead y is some constant. Y is always a certain number. So let's say y, whoops, that was an x. Let's say y equals -1. So what this means is no matter what x is, y is always -1. So here's that spot. This line goes right through y equals -1. And it doesn't matter what x is. If x is 1, y is -1. If x is -3, y is still -1. So that's my slope for that one, or my line for that one. Now how about the slope of this line? What would you say about that? Okay, this one we can do. The slope is 0. If you plug in 2 points from that line into the slope equation, you're going to have some fraction that has 0 on the top. And math can handle that fine. Try to divide a number into 0, the result is 0. So horizontal lines have a slope of 0, and that makes sense. It's a flat line. It's not going up or down, so slope is 0. Okay, so cut. Action. One last segment for this lesson. 3 equations, we're going to graph them. I'm going to show you the best way to do that. Of course, you can use your GDC to create a graph on your calculator, but being able to make hand graphs is an important skill. It helps a lot. Okay, so here's our first one. Take a look at that equation. What form is that? Point slope. We have our information for our point right there and our slope right there. So let's write some of this down. Slope is 0.5 negative. So it's -1/2. Now the point, this is tricky, okay? Because here's the y1 and here's the x1. Here's our point slope form. The negatives are here in the form of the equation. So for example, the only way to get -2 for y2 in the equation is that if y2 is actually +2, then when you plug it in, it's going to be -2. The same for x, it's going to reverse. So our point is -3, 2. Tricky, you just have to remember that. Okay, so now I have a slope here, -1/2, and a point, -3, 2. So let's do the point. -3 up 2, there's my point. Now my slope is -1/2, so that means if I go over 1, I go down 1/2. I'm going to go over 1 again and down 1/2, and I'll get to this point, which is -1, 1. And then I can draw my equation, my line graph. So that's that one. Okay, let's take a look at the second one here. This one you should be able to do. We've actually done one similar to this already. So go ahead and pause the video and make that graph. Okay, let's see how you did. My y-intercept is 5. 1, 2, 3, 4, 5. I go right to that point, and my slope is 2/3. So it goes up 2 and over 3. So up 2 and over 3. So if that was 5, this is the point 7, 3. And there's my line. Okay, now this last one is a little tricky. You'll notice that that's in standard/general form, and we want to put that on the graph. So what's your first step? Think about that for a minute. Okay, if you said convert it into another form so I can graph it, you're right. And that other form is almost always, this is the best form for graphing. As you saw making this graph, it was pretty simple. So we have to convert this equation into gradient-intercept form. So that's just solving for y. So let's do that. I'm going to subtract 6x from both sides. I get 2y equals negative 6x. I still have my plus 1. So I have 2y plus 1 equals negative 6x. Now I'm going to subtract my 1 from both sides. 2y equals negative 6x minus 1. And then divide by 2. Y equals, now negative 6 divided by 2 is negative 3. 3x minus 1/2. So now I have it in gradient-intercept form. Now I can readily graph it. So the y-intercept is negative 1/2. So that would be right there. And my slope is negative 3. So I go down 3 over 1. So 1, 2, 3 over 1. We put that point right about there. Kind of missed my point, but you see how that works. Now that you've watched the video, take a moment to jot down any additional notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.